All right, Big Data Applications and Analytics, Geoffrey Fox Instructor, Lesson 7, Fourth Paradigm. So now we're coming to something which is quite important for me as a researcher working in scientific research. So this is how we change the way we do research and how the same thing that's transforming e-commerce is actually transforming research. And this way it transformed research is called the fourth paradigm. That's because the first three paradigms are more old-fashioned. Paradigm one is basic scientific discovery, theoretical. Paradigm two is observational approach, very classic, watching apples drop from trees and things like that. Um, Paradigm three was caused a lot of excitement when it was introduced, maybe around 1980. That's simulations, computational science, and the fourth paradigm is data-driven science. The data has the answer. Previously, data was used to check the theory. That was the whole purpose of your data. Now, the theory's in the data because we have so much of it. That's the whole point about data-driven work. Thank you. So here we have a screenshot from a Wired article, Wired issue of September 2008, and it has this dramatic title, "The End of Science." And welcome to the petabyte age. Actually, we just explained we're really in the zettabyte age. There's just petabytes per field, or up to maybe 100 petabytes in some fields. So this I think this particular article was very influential in bringing this idea to people's attention. And its title, although quite wrong, it is, I say, actually in some sense the beginning of science done better, not the end of science, but it brought these things to people's attention. So we have these four paradigms of scientific research. Everybody agrees about theory. That's what Einstein invented with his equations, or Newton's invented, or the superstring theory is a theory. This is a way of thinking about the world with equations traditionally, or maybe which told you what's going on. Then we always had experiment and observation. And that experiment and observation gave data, which gave information, came knowledge. And for instance, Newton's based his theory on apples falling from trees. At least that's the claim. So that's the second paradigm. So for a long time, until maybe 1990, people always identified two modes of research. Then along came lots of computing, and that led to so-called computational science run on supercomputers, which added to this repertoire the ability to gain knowledge by simulating a theory. And that simulation would tell you maybe things that you could never see from experiments. And so that allowed you to get scientific insights of a new type. Now we have this so-called fourth paradigm. And what's somewhat controversial is whether the fourth paradigm is different really from the second paradigm, because like the Large Hadron Collider, it was always called experimental particle physics. But it's the world's biggest data in terms of science. And so is it the fourth paradigm or the second paradigm? Not so obvious. What's characteristic of the fourth paradigm is that you're using the data to drive the discovery or to drive the scientific inquiry, whereas traditionally you use theory and things like that. But actually, whatever you look at, you should probably be aware of the theory, because the theory will guide what you do. And it is wrong to think that the data-driven approach gets rid of theory. Like even Netflix, which is using purely data-driven approach and its data science, consumer data science, it is actually using some sense, if not theory, at least thought, because they choose which parameters to look at, or they want to look at things connected to you, things connected to your family, and that counts because they know people, individuals, and families watch TV at the same time, and they know various categories that you're meant to look into. So that their so-called data-driven approach is actually guided by theoretical insight. There's this famous book from Microsoft on the fourth paradigm, a free book you can download, and I recommend it. It's again, whether it's method 2 or method 4, is still pretty interesting. So, okay, here is the final slide in this short segment. And this fellow always looks pretty cheerful to me, scooting around in Silicon Valley. He, at the time, which is probably, these things usually change, in 2008, he was heading Walmart Labs. And he was teaching a guest class, and he was addressing the famous Netflix challenge competition, which is trying to produce a better way of predicting what people want to watch. And that uses machine learning, a nifty classification algorithm. And he had student teams, and he contrasts two teams. One, brilliant mathematicians came up with a much better algorithm, and team B used a very simple algorithm but added more data, especially data about the types of movies from the Internet Movie Database. So this was actually what I told you about theory. The theory was either use the raw data or use the raw data plus another data. The team that used a better theory got the better answers. He actually interprets it differently, that more data produces better algorithms, but actually it's a contrast between thinking carefully, which says we really should add this type data to the data we're looking at, as opposed to doing better mathematics. So mathematics is not the same thing as theory. Theory needs real insight. So that's a reasonably important observation. Okay, thank you very much. The end of this lesson. Unit 2, Course Motivation, Lesson 7.